Hi guys, hope all of us are doing great. My name is Ernest and this is Ernest Sciences and Mathematics TV channel. So on the display I've given three specific illustrations, and these are going to assist us try to comprehend the process of oxygen intake into the blood and the outtake of carbon dioxide in that specific order. So for the case of blood transport, I mentioned that gases are going to diffuse into the blood between the lungs and the body, and this is going to be facilitated by the diffusion gradient or the partial pressure which is going to exist between the blood capillaries and the adjacent cell environment. So in this particular case, we're going to see that these specific airs are going to diffuse in form of aqueous form or a moist form. And of course, as we can see from these specific sections, they are going to be forming in or be carried in forms of these specific aqueous forms, as we're going to see later for the carbonate. And of course, especially for the carbonate section, we're going to see that it's going to be carried in form of an ion, which is illustrated in that specific equation. Now, in this case, for oxygen, oxygen is going to bind to a protein that is going to be referred to as a hemoglobin, and this is going to be occurring in the red blood cells. So in this particular case, I've just given this illustration particularly to show this particular range of cells which are red blood cells, and these are going to be forming a vital part or a vital playing a vital role in ensuring that the exchange of oxygen between the in and outer environment is going to be successful. Now, the binding of oxygen and hemoglobin is going to form an unstable molecule that we're going to refer to as oxyhemoglobin, and this is going to readily release oxygen in regions whereby the partial concentration of oxygen or the partial pressure for the concentration of oxygen is going to be low, as we had discussed in our previous video. So therefore, in regions where the concentration of oxygen is low, especially in the adjacent cells environment, then therefore this particular molecule is going to dissociate and release oxygen into those specific regions, whereby we're going to see that carbon dioxide is going to be, of course, in a high concentration, and it's going to be released in the environment in that specific order. So this specific illustration for the movement of perhaps compounds and ions and gases, of course, in aqueous form is going to be, of course, the specific reactions which are going to be taking place, or the chemical changes which are going to take place in order to ensure this exchange of gases. As we said, this is going to take place in a most aqueous environment, and therefore this is going to be an elaborate process which is going to be given in terms of those specific ions and molecules. So as we said, that oxygen is going to be released from the hemoglobin, and of course, whenever the levels of carbon dioxide in the blood have increased, this is going to be a subsequent process that is going to take place to ensure that there's intake of oxygen. Or in cases whereby the blood temperature has increased or the blood has become more acidic, this oxyhemoglobin is going to dissociate and release oxygen into the adjacent environment. Now, in our next video, we're going to see the elaborate process of carbon dioxide, which of course is going to be taken from the muscle cells or the adjacent cell environment or the body tissues into the blood, of course, capillaries, to be taken out as a product of respiration. So in this particular case, I'd like to invite us to our next video, where we're going to look at the concept of a carbon dioxide exchange or transport in the blood and the lungs in that respective order. So that is it for now, guys. Catch us in our next video. Bye. God bless.